It's time to get started already. How are we doing? Sprint 2 happening?
Sort of.
This is one of, if not the most challenging sprints. So from what I have seen and heard from multiple groups is that things are challenging, and getting everything ready for tomorrow's client meeting is going to be a rush, bit of a crunch. That's understandable. Do your best, have the most that you can, and think about prioritizing those features. The client doesn't care about things like unit tests. The client doesn't know or understand anything that goes on underneath the hood. If there are some very side features, if you haven't perfectly split everything into MVC yet, the client will not care about MVC. Doesn't know what that is, but the client will be able to mess around with the user interface and try to figure out, all right, how does this GUI work? Can I do my workflow in this GUI, even if not every single feature is up and running yet? Does this workflow make sense? Does this look nice? Will this scale to the kinds of projects that I want to be able to utilize the application for? Those are the kinds of questions that the client will be asking tomorrow. And then, of course, you have between tomorrow and Sunday to get everything else working. So focus on just those tasks.
We're also gonna get the sprint 3 requirements, right?
Yes. You will be getting the sprint 3 requirements, but don't worry about starting those until Monday. There's a peer review due tonight. So make sure that you're filling that out so that I know how the groups are doing. I know especially as things get very stressful, that I want to make sure that everyone is giving it their all, whatever that looks like. Of course, within the scope of you have other classes, you have other life is happening outside of just school. But that said, there are requirements that need to be spread across the group. So just make sure that everyone is pulling their weight. And that way I can reach out to people for whom that is becoming an issue. Is there anything else I need to address? I don't think so. Client meeting tomorrow. Tony may be a little bit late to that, so I'm in the process of trying to figure out for the first couple of groups, what is a backup plan? Do I play the role of a client? Do I try to recruit some alternate persona of Tony to stand in for Tony? So keep that in mind. If you decide that you want to go first or second, you may have a completely different client who has no idea what they're doing and is learning on the fly.
AI model trained on Tony.
Yeah, there we go. Darn it, I should have had ChatGPT looking at and analyzing this the whole time, just to be able to emulate it. I've been looking. I can play that role. No, I can't. I'd be way too insane. All right, last time we were talking about design patterns. We got through most of the creational patterns. We just had prototype left to go. Then we were going to look at the structural and behavioral patterns just to get you familiar with them and what their use cases might be. As I mentioned last time, this is way faster than it deserved. We're learning these from scratch. So there will be some outside of class studying that just has to happen in regards to these because there's not enough time to do them all justice. All right, so prototype, last creational pattern. The idea behind it is that we want to copy different objects. You can especially imagine that you have some kind of inheritance hierarchy and you want to copy objects without making the copying code dependent on the actual underlying class. You want to be able to copy something kind of in the abstract. Call the same kind of copy code without having to call it on a particular object. So this is probably, if not my favorite, then a top 2 or 3 image in this entire refactoring guru of the idea of trying to copy a plane from the outside. If all you're doing without looking inside the airplane to try to figure out how it works is you're just looking around the outside of the plane and trying to recreate the functionality of a plane from the outside, Then a month after that, you are able to reconstruct the exact outside of the plane. So from the outside, it looks like a plane. Does it function like a plane? Probably not. There's more going on with the internal representation of the plane. So it would be much better if the plane itself knew how to copy itself. So we have an object, we want to create an exact copy of it. We have to create a new object of the same class, then go through all of the fields and all of the methods and copy everything over into the new object. Really just the fields, the methods come for free, but the fields have to be copied over at their exact values. And that's how we're doing a deep copy of an object. We recall the difference between a deep copy and a shallow copy? Raise your hand if you have no idea what I'm talking about or forget it. All right, so a shallow copy is the equivalent of there's one of me. Do we agree with that? There's only one of me sitting here. If someone were to say, hey, Dr. Kane, I would turn and look. If someone were to say, hey, Chris, I would turn and look. There are two different names, but only one object. And those two references to that object refer to the same object. The example that I like to use in something like 212 is you get so frustrated with me, you walk up and you punch me in the face. Both Chris and Dr. Kane are experiencing pain. You ask, hey, Chris, are you experiencing pain? The answer is yes. Hey, Dr. Kane, are you experiencing pain? The answer is also yes, because there is one object. If you do something to one named object, you're doing it to the other because there's only one object. All you've duplicated is the reference, creating an additional name to refer to that same object. And it works exactly the same in code. You have an internal data representation of an object. Maybe that's a linked list, and you want to pass that linked list to another method. You're not duplicating the entire linked list. Even if the parameter in that other scope has a different name to that object, and even within the same scope, you can create a reference to that object without having to go copy all of the internal memory of that object. So a shallow copy, just making a new name for that same object, you're not duplicating the object. A deep copy is you're taking the object and you're literally cloning it piece by piece, and then having a different name referring to the different objects. You can imagine I cloned myself, and you walk up and punch the clone, I go, haha, I fooled you, I experience no pain. Well, the clone regrets its existence. So, deep copy, shallow copy, with an unfortunate, violent example. I find that sticks for some reason. I used to use different examples, and ever since I started using violence as an example, people have perfect recollection of it. I don't know what that says about computer scientists, but it works.
No, it's just sex, drugs, violence, all those sticks.
Oh, there. And probably talking about sex and drugs as an example is probably not the direction I want to go. Violence of those three are probably the most useful or relevant in a classroom setting.
You're forgetting about rock and roll.
Maybe that's the one we should attach ourselves to. So yeah, not all objects can be copied that way, because if fields are private, then we don't have access to those from the outside. So if I want to create a clone of an object from the outside, I have to know its internal state or have access to its internal state. And if it is well encapsulated, then I should not have access to the entirety of its internal state. Which means that the only thing that can copy the object is itself, because it has access to its encapsulation, its private fields, its associated behavior. The only way to clone an object is from within itself. So, since you have to know the object class to create a duplicate, your code becomes dependent on that class. So you have to write separate cloning code for every single class that you have. But the prototype pattern now, of course, is going to delegate the cloning process to the actual objects. And then we're going to further delegate the cloning process into a hierarchy. So objects could have dozens of fields, hundreds of possible configurations. The example that I like to use for this is something like D&D characters. I don't know why I attach myself to it, but you can imagine something like, I want to clone a swimmable creature. You could start doing all of the work to clone a swimmable creature in ways that works, or you can start making the associated movement behavior of swimmable creatures. We don't know the speed at which, we don't know the size of a fin, we don't know how exactly that is working, but we can start to have an inheritance hierarchy for that process. And the cloning code can now be associated with the same kind of inheritance hierarchy that you might have within specifying different creatures in a D&D world. So it's very similar to the idea of division of a cell, but we now have the client, which goes through the prototype interface to create a clone. The client says, I want to clone this object. The prototype goes through the concrete prototype and the subclass prototype to be able to create that object, to clone that object, and then return the object, the cloned object, to the client. So the client is no longer responsible for the cloning. The object is responsible for it, but it has kind of, again, a director, this prototype, that's going to be able to determine the most efficient way of creating that clone. Piece by piece from the associated hierarchy. So as an example, we want to clone a button. So we go through the prototype registry. Then that accesses the prototype itself. And then the button extends that prototype. Sorry, implements that prototype so that we actually get the ability now to, through that prototype, we can see that through that interface, we can clone anything that implements that interface. So the prototype registry can clone anything that implements that interface, and now that interface is responsible for calling the actual clone behavior that's inside of the object that you're trying to clone. So the button now can see its internal state, its encapsulated internal state. It creates the clone. It passes the clone through the interface back to the prototype registry, which can pass it back to the client. And this is much more scalable in nature, because now as we implement other prototypes that can clone from this with the same prototype registry, the client can use the same interface to clone any object. It just has to say, I want to clone this thing. And the prototype registry gets the item however the client wants to find that item. So I can find the button by ID, or find the button by color, or so there's some collection of clonable objects that is in the registry. The registry searches for the associated item, goes and finds the interface that clones that item. Then you get that clone pulled out from that object's internal state. So again, from the client's perspective, it's as easy as possible. But this is also very easily extendable in that you can make modifications to the associated prototype registry and add clonable objects. And then the client with the same functions here can go find any object that has been added to that prototype registry. And whenever you create a new clonable object, you just add it to the prototype registry as a clonable object. And then from the client's perspective, nothing has changed, except now there are more items that I can go find and I can go clone. So incredibly useful for object construction when there is cloning involved. Does that make sense? Questions?
Any use of this pattern other than cloning?
It's really meant for deep copies of objects. And that's it. You can, on object construction, sometimes it saves you a lot of time. Rather than making an object from scratch, you clone an existing object and then go modify it. And from the client's perspective, it'll be a lot easier than something like having to specify every possible field and method. So you can imagine in your UML editor, if you wanted to make an object that was a subclass of another class, you could, instead of typing new class or saying add class, and you wanted to add a new class and add every single thing, you could duplicate or clone an existing class, get all of the associated functionality, and it would be less work for the user to change that, to modify the existing deep copy of an object than to create a new one from scratch. That would save them time. Even if from the computer, it's a little bit more work. to clone things and then modify them rather than make them from scratch. It's such a short, simple process that saving the user that time is worth the associated complexity in the code to give them that functionality. So if you're considering adding functionality to your UML editor that is a duplicate, think about the prototype pattern. Other questions or thoughts on prototype? So of what we have discussed so far, I think factory would make a reasonable amount of sense to try to add to a UML project. I think prototype makes a good amount of sense. There may be something that you want a singleton of, something like a swing or FX canvas. You wouldn't necessarily want multiple canvases open at the same time, or would you? Would it be reasonable to restrict that? Is there anything else that you'd want to restrict to a singleton of? Is there any object that you want to delay the construction of? Or finalize at a later date that would make builder work for that? There are quite a few creational patterns that you can slot into our UML project. All right, you ready for some structural patterns? Truly thrilling material, this. I find that when I teach this in 212, no one can stay awake because you don't really have the ability to go apply this. So we're talking about it all in abstract, and it just makes no sense to do that. It makes so much more sense in 350.
I just fell asleep in the atrium. I don't think it's about.
But when you can actually go apply this to something and see the benefit, it's so nice. So adapter. The adapter is a very easy pattern to understand because it works almost exactly like an adapter that you would think, just like a cable adapter. So basically we have some plug want to put into a wall socket. And the plug that we have is not the same as the wall socket. So we can't just plug and play. If we have an adapter, we can plug the plug into the adapter and the adapter into the wall, and we have an additional piece that facilitates that communication. This is most useful in legacy code if you're updating legacy code, but don't want to change or represent all of the associated, you don't want to update all of that legacy code. You just want to say, the legacy code works. I want to take what functionality I want to add to that, and the adapter will then convert the way that you want the user to interface with the system with the underlying system. Now, that is a hacked together solution that does not work for very long. But if you really only need that one change, then the adapter can make sense to save yourself a lot of time. So the example that we use here is a stock data provider looking into an analytics library. And the issue is the data provider and the analytics library are looking for different things. The data provider is providing data in XML, a data format, and the analytics library is stored in JSON, another data format. So if we wanted an application that reads from the data provider and writes to the analytics library or vice versa, you would think that what we really want is an XML to JSON converter or a JSON to XML converter or something of the sort. If you're thinking of writing this converter, what it really is an adapter pattern. Because you're going to take in just like one chord being the XML, and you're going to plug it into the wall that is the JSON. And then what your adapter does is takes the input and converts it into the output that is needed to communicate between those two systems. So it's the exact equivalent of using a chord-like adapter. Of course, the larger scale project would be to convert the XML data provider into JSON. Now, that would be up to you, the designer, to figure out, is the work to convert how an entire system works worth it? Because what if that data provider is engaging in XML and other formats? That's not necessarily this application is not the only use for that data provider. So sometimes it's not worth it to, maybe you don't have access to that data. Maybe you're just pulling that data and you want to fit it into a library that's already in JSON. So rather than converting all of the JSON into XML or asking the owners of the data, hey, would you mind converting your entire XML into JSON to make it easier for me personally, and who cares about the rest of your clients? You could just write a converter and then they don't have to do anything. The library doesn't have to do anything, and that converter will always work between XML and JSON. May not be a long-term solution depending on the problem. It may be a long-term solution depending on the problem. You can also have two-way adapters converting in both directions. So yeah, you just have an XML to JSON adapter that then you slot in between where the XML is needed and where the JSON is needed. You feed as input XML, you export the JSON, and it's like they're communicating directly. Think of it as well like maybe Google Translate is an adapter between languages. I speak in one language to Google Translate and then hold my phone up to someone in some other country where I want something. They speak that, Google Translate speaks it in the other language. That's the adapter between our communication. We can't communicate directly, but through an adapter, we're able to communicate as if we're talking to each other directly. So again, it's exactly the same kind of idea. Okay, this is one of the funnier images as well. The first time you travel abroad, you take the necessary things, and the 10th time, there are way fewer necessary things and a bunch of adapters, especially if you're traveling to Europe, where every country has a different needed adapter. So all it is, a client interface, the adapter is going to implement that interface and then provide the associated service. So the adapter is between the client and the service and converts between the client speak and the service speak. Takes whatever the client wants, converts it into the service's request, takes the service's response, feeds it back to the client. And that's a two-way adapter in that case, communication in both directions. And you get what you want. Questions on the adapter? Does that make sense? Yeah.
I'm a little confused on how it's a pattern. It kind of just seems like it's a class that you would have.
Yeah.
Not sure what makes that a pattern. How do you?
A lot of the times it is just a class or a set of classes. What makes it a pattern is the client interface and the fact that you can have realizations of that adapter and you can make multiple adapters for different needs. It kind of becomes like a multi-adapter where you take the same input that can feed to 3 different outputs, or 3 different inputs feed to the same output. So you can start to use inheritance and realization both to create a multi-pronged multi-to-multi adapter as needed based on that system. But a lot of these really are on the simpler side. Prototypes on the simpler side, adapters on the simpler side. But there are issues with object-oriented programming in general. All right, bridge. Bridge is fun. So we have a large class or a set of closely related classes, and we want to split them into different hierarchies. The hierarchy of the abstraction and the hierarchy of the implementation, which then we can develop independently of each other. And let's see exactly how this looks. So we have a design that is a shape and a color. And we see how the subclassing for this can explode in nature, where if we just have one superclass for shape, then we would have to create subclasses for every combination of color and shape. So we have subclasses here for red circle, red squares, blue circles, and blue squares. The question that I have for you is, now we're going to add a color. How many classes do I need to write? I want green.
2 more classes.
2 more classes? Let's say that I wrote those 2 classes for green circles and squares, and now I want to add a triangle. How many classes do I need to add? 3 more. What if I wanted after that to add another color?
Lost count.
4, and then it's scale, you have to write an additional class for every single one that you add. So it becomes 3, then 4, then 5, then 6, then 7. It's a geometric scaling on the number of classes that you need, and that scaling is independent, but it still scales for each of the 2 hierarchies. So wouldn't it make more sense to split this in some nature and compose an object out of both a color and a shape? Then the object, when we add something, we'd only have to add one thing rather than as many colors or as many shapes as we had. So this is a very scalable design pattern, where if you envision later on the client wanting to be able to, or you coming back to this code and being able to add additional colors or shapes to your code, you want to minimize how much work that refactoring is going to be. You don't want to write 10 classes sometime in the future because of a poor design decision you made at the very beginning. Once you're so deep into this and you have 700 classes of color shape pairs and you realize I really should have done something different, how much work is it going to be to refactor those 700 classes into a better idea? It's going to be a ton of work. So designing this from the ground up allows you to say something like, all right, our shape now is an inheritance hierarchy that is a circle and a square, and it has a field inherent in it that is its color. Does it make sense how these are 2 different designs that represent the same idea? Where color is now a field inside of shape instead of inherent in the object itself. We find dimensionality in class design all the time, and it's not necessarily as straightforward as shape and color, but you will find that in your class designs, you have inherited some dimension and you're duplicating classes for every element of that dimension. If you see yourself doing that, apply the bridge, and it allows you to now collapse all of that into a single field that is now a composition than a duplication of ridiculous numbers of classes. So now, how much work is it to add a shape? How many classes do we need to write? 1. We want to add a color. How many classes do we need to write? 1, and it's independent of the number of shapes and colors we already have. So it turns a scalable amount of work and turns it into a constant amount of work to be able to add to it. And that's basically the entire idea of bridge. You can think of this kind of similarly if you have something like an application that has different frameworks for different operating systems. If you make that a field rather than a completely different class, then when you want to add a new operating system support, you don't have to duplicate all of that work for everything that you've done so far. Whenever you add a new feature to your app, you don't have to make a new class or figure out a new way of how am I going to interface this with the existing Mac framework, the existing Windows framework, the existing Linux framework. If it's a field, you just plug and play. You might have to add an adapter to that, but now at least in the design, you're not writing multiple classes that scale to each side of the framework as you add support for a different operating system, as you add support for a different feature. So here's our UML. Client works through the abstraction. The abstraction is composed of the implementation. Then we have the associated concrete implementations, so that when we add implementations, it doesn't change anything from the client's behavior. The client still interacts through the same abstraction, and now, after deployment, we can easily add refined abstractions or concrete implementations without changing how the client interfaces with the abstraction. We're going to talk about API design in a week or so, and API design is really important. I'll hint to that at the moment. If you force the client to go through the refined abstractions or the concrete implementations, you have to change your API whenever you add functionality. And that means that the client has to change their associated workflow or be aware that certain things, if they're working through an abstraction, then you can add functionality without changing how the client interfaces with the code. And that allows you to add functionality in ways that don't disrupt an existing service. Questions on Bridge? It's just dimensionality reduction. All right, composite. This is going to be taking related objects and coming up with an associated tree-like structure that allows you to define the associated substructure. So you can think recursion, you can think breaking larger objects into smaller objects, packaging smaller objects together into larger objects, and we can now work with the larger scale objects. So the example that is used, I believe, is something like, imagine the packaging work that goes on at Amazon. If you want to order 7 different objects from an Amazon warehouse, you could either have 7 different delivery drivers come deliver 7 different objects, or you can find an intelligent way of, from this part of this warehouse, package these 2 objects into a smaller box. From this part of the warehouse, put these 2 objects into a smaller box. Have someone gather this box and put them together in a larger box, wasting a ton of cardboard and murdering entire forests along the way. But in the end, there's one package to pick up, and it may minimize the amount of work that's done in the associated warehouse with regards to traveling around the warehouse, identifying the objects, and rather than moving this object over and then this object over and then putting them all in one large package, you can multi-package, and that way you're moving the same or multiple objects at the same time. It's very similar in terms of a code-based order. So we have our objects, the phone and the headphones, since they're meant to be used together, I guess, or come together, go in a box. The charger goes in a box. A hammer goes in a box. The phone-related objects go together in a larger box, and then the smaller box, the larger box, and the receipt go together in a larger box. So it breaks down into kind of a tree-like structure where now have different levels of abstraction, and we can identify different pieces of this order at that different levels of that abstraction. So we would have a products interface, a boxes interface. A box can contain products, and that allows us to do something like determine at any level of this hierarchy what the price of the objects that are contained within the associated box that you care about is. So we could query something like the price of the complex order, the price of the hammer, the price of everything related to the phone, the price of the phone and headphones, the price of the charger. And we would have the ability to, in this entire hierarchy, query something like that. It's very much like a military structure as well. So client goes through the component interface, which goes through the composite. We have the ability to add, remove, and get children, which is going to be the boxes inside of the box. And then a leaf is an object, the actual object. It's not a box, it is an object inside of a box. That is not a box. So the actual items in the order are leaves, and the composite are the boxes that put the leaves together into their associated structure. So useful when you have complex ordering, complex subclassing, if you want to be able to identify and break apart something into its complex substructure. If it just seems like inheritance, it's just kind of a more structured, multi-leveled inheritance. Questions on composite? right, to the decorator. One of the first ones covered in 212, one of the ones I hope those who've taken 212 know pretty well. The decorator, also known as the Russian doll, also known as, so this allows you to place an object wrapper over something that says whatever it was, now treat it like an object. So we can attach whatever an object used to be, you can add functionality to that object by placing it in a wrapper class that just adds that associated behavior. And this can save you a lot of time with regards to going and completely refactoring that object. This is not a one-size-fits-all kind of problem. You can imagine that if you wanted to make a graphing calculator, but you didn't want to implement the entire functionality of the actual calculator part of it, inside of the graphing calculator, you would have the calculator component. And then you would wrap that calculator component with the ability to visualize a linear function or a visualize something. So you'd wrap it with the behavior of being able to graph the result, but not change the underlying behavior of the actual calculator. So you don't have to reinvent the wheel, you just add the functionality to the object that you want. But if you don't want to modify the object as is, you take that object, you make it the field of a larger scoped object. And then you add the behavior into the larger scoped object that takes that field and emulates that behavior to add that new functionality to that object. Does that make sense?
So it's like importing a module?
Kind of, except you have access to the class right there. If you're importing a library or importing a module, the code is there, but it's not something that you wrote or have access to. That's a good question. So let's say we have, this is still part of the problem. So we have notifiers that come from different sources, a text notifier, a social media notifier, a work notifier. So we could continue to do this, but now if we wanted different combinations of these, you can again see that this explodes in kind of geometric complexity as we now need to, if I want to subscribe to both a notifier via SMS and social media, or SMS and work, or any combination thereof, we end up with, again, significant amounts of subclassing that we need. And in general, for design patterns, if you find yourself exploding your number of classes to represent combinations of things, there's almost always a design pattern that you can put in this to remove the associated complexity of that. So instead, we're going to subclass this to inheritance and aggregation. So we end up doing something like this, where the decorator over the SMS, Facebook, and Slack decorators are going to now be able to send the associated message. And that's the only reason that we needed to duplicate all of those classes, is we needed to add the functionality now of how does each one of these in some combination send to this, send to that, send to the other thing, send to this and that, send to that and the other thing, send to this and the other thing, send to this, that, and the other thing. We needed all of those combinations, but now we have a decorator for the notifier that allows us to now subclass this and use as inheritance so that we can add wrappies to the decorator, and then we can send that to the notifier. And now the notifier, based on the base decorator, sees what components it has. Does it have certain combinations of SMS and Facebook and Slack decorators in a way that says, for each object that this is composed of, send the associated message via the inheritance hierarchy. Each object knows how to send its associated message. So now the notifier send message is really just a loop over every object in the decorator to send each of those individual messages. How are we doing with that? Does that work? So you've kind of Russian dolled this, where you've taken an SMS and a Facebook and a Slack decorator, and you've wrapped the behavior of how to call all of their send message into a new object. That is some combination of those. And then that's what is a subclass of this notifier. So the notifier, when it sends the message, goes to the decorator says, what am I composed of? Breaks it into those objects, saying for each one of those objects, call your send message. If one of those objects is a Slack decorator, then it will send that message on Slack, because that is how the Slack decorator calls it send message. Questions on this? Again, wonderful real world analogy. The layers that you have on have nothing to do with the underlying base functionality, but it changes kind of the behavior that you have in the environment that you are in. If you dress in enough layers, you're not cold. So we have our concrete decorators beneath the base decorator that composes them. Then those combine into the associated components with that interface, and then the client interfaces with that. If the client says, send all notifications for what you have determined, then you were able to do that by breaking it down into its decorator and to its components. Questions on decorator? All right, facade. So facade exists if you're going to try to make code work over a large number of objects belonging to a significant number of different libraries, different frameworks, something that's different amongst the composition of what you need. Normally, we need to initialize them all, keep track of all of their separate dependencies, because each one of these objects needs to import different libraries, needs to utilize different things, execute methods in different orders. So the logic of your classes becomes coupled to the implementation details of third-party classes, which means that if you're maintaining your code, it's dependent on the maintenance of a bunch of other code. So when something changes in the associated maintenance, then you have to change something, etc. So we have placing orders by phone as the example. Someone calls into a call center. The call center now has to figure out the associated warehouse, packaging, delivery, payment processing, suppliers, and taxes that are all interrelated to all of that. And if any one of those processes changes, the payment processing changes, then the phone operator needs to know something about how to handle the initialization of the payment processing, because that has changed. If the taxes change, then the person who is on the call needs to change the total that they give to the person who's calling in. So there are a ton of dependencies associated with the placing of the order by the phone. But if you package all of them together and make it so that the call center now interfaces with some combination of those in ways that if a change is made to one, then it interfaces with the facade to be able to structure all of that together. Like the facade of a building is what holds up a bunch of different components. This is the facade that's going to hold up all of those different components. It's the equivalent of the call center person who is aware of all of those changes, or has a system that is aware of all of those changes, so that the communication between the client and changes to the warehouse, packaging, delivery, etc. all work. So we have a bunch of annoying subclass systems with their own dependencies. The facade takes care of all of the associated links and the associated functions, such that when the subclass systems change, the facade handles it so that the client doesn't have to know how to interface with all of these subclass systems. The client only has to know how to interface with the facade, the facade handles all of those dependencies. Questions on facade? We'll probably get through one or two more. All right, flyweight. Fitting more objects than we otherwise could into available amounts of RAM by sharing state. Whenever we have two components that utilize the same memory, if we can identify that and then make kind of a shallow copy of that RAM, then our applications use less RAM. So the example that is used here is some particles are shared in common between different animations. And rather than recreating particles, if you're reusing some of the existing particles, then you don't have to generate quite as much. So here we have a game that uses a bunch of particles. Each of the particles are made up of a bunch of units, and each particle has the coordinates, the vector, the speed at which it's moving, the color of the projectile, and the sprite. And we can imagine that each one of those takes about 21K of space, and there are 1 million projectiles on the screen at the same time. They're playing Path of Exile. So of course, now we can change a particle into a moving particle, and if the particles move into the same space and have the same something that's going on with that, then you can, rather than tracking each particle separately at that point, you can start to create the same state out of it that only displays as if it's one particle, even though you're tracking two particles, the actual display of it, one particle state kind of becomes the other. So we do this and we can turn the associated RAM cost from, this is 21 gigs because there are 1 million of them active at the same time. And now we have the moving particle class that tells us the associated relevance, and the particle itself now only has the color and the sprite, not the coordinates, the vector, and the speed, because as those become more and more, rather than we can combine that into, split apart into what is independent of each other at that point, and we end up with a significantly less memory footprint on our particles. Yes, flyweight and factory go together very frequently. Factory for pools of existing flyweights. So a general flyweight factory making different kinds of flyweights that utilize the associated context for what does it mean to be in a unique state? When is there overlap between those unique states, and when can we drop computation on that? Questions on flyweight? I assume that all of these need significant additional research from everyone's perspective. Again, not going over these anywhere near detailed enough for you to be able to reproduce them, but that's what the code examples are for, etc. I just want to give you an intuitive idea of when to use each of these patterns so that you can identify, this seems like a time when that was that one pattern, you could apply this idea. All right, we have time. I think we have time for proxy. Substitute or placeholder for another object. So the proxy controls access to the original object, performing something before or after the request gets through to the original object. So if there are a ton of different clients communicating with an associated database, then the database can become very slow at responding to all of these clients at the same time. So we want to control access to the database and allow for an associated priority, or to manage the database's resources so that maybe there's some kind of queue for the clients, or that there is a priority associated with different requests. If an emergency service tries to access a database, then some random person who's trying to access that database won't be prioritized to quite the same example. So massive object consumes a vast amount of system resources needed from time to time, but not always. Then the proxy can slot between the database and all of the clients. It disguises itself as the object that you're trying to do, and that allows you to do things like cache requests. If the clients are always asking for the same kind of request from the database, then you only ask the database to return something that is not stored in the proxy cache. And that way, if repeated information comes in from the client, the proxy is what's returning a lot of the information rather than the database, and that keeps the database performing at a high speed. Because it's not handling everything. You have some proxy handling something like that. So we have the service interface, we have the proxy and the service. If the service is a typical service infrastructure, sometimes the proxy can handle it. Because it is the same service that the service already provided, so we can emulate it on the proxy without dealing with the system that has the limited resources, which is the service. And now the proxy can just make sure, check access. Should you have the ability to get this data, it allows you to provide encapsulation around the proxy. So if you had to log into something to access the database, the proxy can do the login request without the data fetch, and it still saves time and resource. Questions about proxy as we pack up? All right, probably have one more day of this. We'll do that on Thursday. And we'll dive into things that are a little bit more fun than design patterns at a high level. Client meeting tomorrow, I will have figured out what the first bit of that looks like by tomorrow. So I'll see you for that. Good luck making progress.